Hello class, welcome to Basic Electronics class. So today we are going to discuss enhancement type MOSFET. So what is the difference between the enhancement type MOSFET and the depletion type MOSFET? In the previous lecture I have discussed depletion type MOSFET, and if you see the constructional diagram, what is the basic difference that you see? There is no channel between this enhancement type MOSFET. See, this is the source and this is the drain. So there is no channel present over here. But in the depletion type MOSFET, the channel was present. Now this is the substrate, okay, and this is the drain terminal, this is the gate, this is the source, and the gate is insulated from the substrate by the silicon dioxide layer. Both the N regions are heavily doped regions. So this is the basic construction of enhancement type MOSFET. Now let us see the operation of enhancement type MOSFET. So first we will see the first case when VGS equal to 0 and VDS is positive. So you see that I have connected the gate and the source terminal to the ground. Hence VGS will be equal to 0. And I have connected the drain and the source terminal to VDS, which is positive. So this is the positive terminal and this is the negative terminal. Okay, so in this case what happens? There is no channel. Okay, since VGS equal to 0, so there will be no channel developed between the drain and the source terminal. Hence no current will conduct from source to drain, means there is the ID current will be equal to 0. So in the first case, when VGS, that is the voltage between the gate and the source, equal to 0 and VDS is positive, then no channel is developed and hence ID current will be equal to 0. Now in the second case, when VGS equals to positive and VDS is positive. So see, I have connected the gate terminal and the source terminal to the voltage which is called as VGS and it is positive, and the drain and the source terminal is also connected to the voltage source which is known as VDS. Okay, so what happens when I am giving this voltage? So the gate is connected to the positive terminal. So what will happen? The minority charge carriers, that is the free electrons which is present in the p-type substrate, will get accumulated here, okay, because it is having force of attraction with this positive terminal, but it will not cross it because there is a silicon dioxide layer which is the insulating layer. So it will accumulate over here and all the positive charges or all the holes will move to this side. So what will happen? As you will start increasing the voltage VGS, a point will come at which enough number of electrons will be accumulated over here and it will form a channel. And a point will come at which the size of the channel will be sufficient so that it will help the current to conduct from source to drain, means the electrons will start moving from this terminal to this terminal. Okay, so hence what will happen? The ID current will flow from this to this, okay, because the direction of the current is taken in the opposite direction. Okay, so the point at which the voltage at which the current just starts to flow, that voltage is called as the threshold voltage, or it is known as VGS threshold. And when the gate to source voltage reaches this VTH, then the ID current will start to conduct. Okay, so this is a very important thing in this, that when the threshold voltage will be reached, then the ID current will start to conduct. Hence the minimum value of VGS that turns the E-MOSFET on is called as the threshold voltage. So as you have seen that when VGS is less than VGS threshold value, there is no induced channel. and the drain current ID is 0. When VGS is equal to the threshold value, the MOSFET is turned on and the induced channel conducts drain current from the source to the drain. Now in the third case, what we will do, when we will increase the voltage VGS beyond the threshold value. Okay, so what we will do, we will fix the value of VGS, and what will be the value of VGS? It will be more than the threshold value, because at the threshold value only the MOSFET is turned on. So we will fix the value of VGS, and that value should be greater than the threshold value. Then we will start increasing the value of VDS. So what will happen? The current will start increasing, the ID, the drain current will also increase, and the depletion region will also increase, and the depletion region towards the drain will be more. Okay, so why this will happen? Because the drain and the substrate, this particular junction is reverse biased. So when you will increase this voltage, so definitely the depletion region which is formed over here, that side, the depletion region size will be more, and hence the channel width will reduce. Okay, so what will happen? If the VGS value decreases, the channel becomes narrower and ID will decrease. Okay, this happens because the depletion region across the gate is increasing. So hence what we see, the MOSFET not only, why it is called as enhancement MOSFET? Because initially there was no channel in the construction, but by the application of proper voltage, we have enhanced the channel. Okay, we have increased the channel, and there is no physical channel which was present. Okay, and the minimum value of VGS of proper polarity that turns on the MOSFET is called as the threshold voltage, and VGS should always be greater than VGS threshold value. So thank you for watching my channel. Thank you for watching the video. If you have any suggestions or any doubts, you can put it in the comment line.